to everyone.
Hi, Mauro.
Well,
Hi, Mauro. Good morning.
hey, good morning, my friend. Nice to have you here on this webinar. Well, good morning again to all the people that have joined. My name is Mauro Hegnoria. I am the sales manager at PATGROUP for EMEA region. And as you know, PATGROUP, it's a multidisciplinary group of companies that were specialized in the equipment manufacture, analyze, advise, and implementation of production projects and technological services. And this opportunity, we're going to initiate with the last webinar called Tablets Coding. It's amazing how all these 6 editions are already over. So it has been a pleasure to have you here. But before we start with this last edition, we will wait 1, 2, 3 more minutes so we can let everyone to join us. Yes. So I will share a video and we'll be back in 1, 2 minutes. Yes. Thank you. Well, welcome back. Before we start with this last webinar, let me inform about the terms. Yes, as you know, the headphones will be shut down to avoid any interruptions. And in case you have any question or comment, you have to proceed the following way. In the lower right corner of the menu, you have to choose the activities option and then the questions answers button. Yes, it is the last option. And once the question has been formulated, we will answer it during the intervals for this purpose. Yes. Now it's time to introduce once again to the professor of pharmaceutical degree, Mr. Arturo Oya, who is in charge of this presentation today. He is a very expertise pharmacist with large experience in R&D production area and with more than 30 years of experience in several laboratories. And it's really a nice colleague and a really good example of well-known about pharmaceutical and process. And he's especially a good person. So now I will leave you with Arturo, that he will start with this presentation. So please, Arturo.
Thank you very much, Mauro, for introducing me. And good morning and welcome everyone. And thank you for taking time to hear our 6th webinar about technology of solid dosage oral forms. Today, the webinar will give an overview about tablets coating. Let me find the presentation. Wait a minute. Okay. It's okay, the presentation?
We cannot see it right now. No, yes, Arturo.
It's okay?
Yeah, now we can see it.
Okay. Well,
Thank you.
as I said, today we will tablet coating, and first of all, let us remember that our vision, our perspective of the production process is quality product and efficiency of the processes. It's very important to bear in mind this question, because in these times where the pharma industry is very competitive, we need to have not only product quality, but two good indices of efficiency. So this is our perspective. Here I show the sequence from the raw material, API and excipient powders, transformed in intermediate product. We saw this in the first webinar. The second step is transformed in the tablet, and today we will present the coating of these units. This is the process. Well, in many cases, this unit operation, the coating, is the last operation. The last operation, but not only the last, but it's a critical operation, because the tablet will be spraying with solvent, normally water, and this requires a very, very tuned process, very controlled, very monitoring process, very automatic process. This is a very important question. This is true because we need to reach an thermic equilibrium into the drum of the coating machine. Coating and thermic equilibrium. Let's read. Tablet coating is a process of continuing application of a suspension or solution on a bed of tablet in continuous movement and with permanent entry of dry air that provides the amount of calories per unit of time necessary to evaporate exactly the same amount of solvent that is applied, and in which the temperature of the tablet is kept constant. This question is not it's very important to be in mind, this, because any disbalance or imbalance between the solvent flow rate, grams per minute of suspension or solution you introduce in the tablet bed, and the calories added per minute by the drying air can determine the spoilage of the batch of tablet. And of course, this is not this is a very big problem and very common in the industry. It's possible if you do the node control, for example, or node monitoring, you can fall in this type of problems. Well, we will come back to this aspect of the process in the next slide. But now I wanted to take a look about the classification, the general classification of tablet coating. You remember that the older coating was sugar coating, and the more modern, relative modern, is the film coating with a polymeric. This film coating with water-based normally, and could be with organic based, but more commonly with water. Water is the vehicle to the suspension of polymeric suspension. Well, in comparison, between them. So, appearance, you have that the tablet coating with sugar have an excellent finish, rounded and shiny, and the tablet with film coating have a preserve the contours of the tablet core. The weight gain in the case of sugar, you have a very high levels of gain weight, 20 to 50, and in the case of film polymeric, is 2 to 6 is very small. Logos and engravings is not possible when you use sugar coating, but it's possible when you use the film. Look at the picture, the photograph. The coating thickness, the thickness of the film or the sugar. In the case of sugar, you have millimeters of thickness and only microns, 20 to 200 in the maximum. The other question is the functional coating. It's possible to do functional coating with sugar? Is not possible. It's very limited to immediate release. But when you use film coating, polymeric coating, you have the possibility to do immediate release, delay release, and controlled release. This is a very important advantage of the film coating. The process time is another question very important in the pharma industry, because sugar coating have to 6 to 8 hours to finish, and the polymeric film 1 to 2 hours for the similar batch size. And the other question is that if you use a totally perforated pen application, is very usual when you use film polymeric, and you can use a perforated pen to make sugar coating. Well, now I wanted to show you, these are some qualities of the film coatings finishing product. It's very, very good. Well, I want to show you this comparison between the conventional pan, this one, and the totally perforated pan called side-vented, because the drum into the machine is totally perforated with holes about 2 millimeters diameter. This is a typical totally perforated pan. So these schemes show us some details. As you can see, this is the comparison. The system in the case of conventional is open and is closed in the case of side-vented. The drum is blind in the conventional and totally perforated in the side-vented. The capacity normally is low in the conventional and high in the side-vented. The application efficiency is very, very important. This aspect is low in conventional and is very high in side-vented process. And the process time, of course, is high in conventional and low or very low in side-vented. Automation, well, automation is minimum in the case of conventional because are older equipment, and you have totally automation when you have a side-vented pan. Well, now I wanted to show you some applications. When do we use the coating of tablet? Well, the polymeric film applies on the tablet or pellet, why not, may fulfill different function. The first function, the common function, is identification, appearance, and marketing. We say this cosmetic coating is very common and the frequency is big. Then you have the possibility to taste making. Taste making is common too, because much of the API, the drugs, have a bitter taste. So you need to cover this. So you using the coating, the film coating, you can neutralize the bitter savor. The other question is the stability of AP, stability of component against the external environment. You can make a barrier to moisture, for example. This is a possibility. You put a subcoat of polymeric, and you isolate the tablet, the core, from, for example, the relative humidity of the environment. Then you put the second layer of coating to finally the process. And you have the possibility to define the profile release or release profile of the active principle. With a film coating, you can do controlled release, delay release, gas resistance, and the other, for example, modify release, extensive release. This is a functional coating. It's very common in the industry. The fifth application for me is not so extended in the world, but is very important. The dosage of an active ingredient into the tablet, the cover, the coating, in the film. This is possible. I work in this subject for many years, and it's very interesting. The application, for example, if you want to separate two API, you have API 1 and API 2 that interact chemically. So you need to separate. So, well, you make a tablet with the API 1, then you cover with the subcoat, polymeric subcoat, and then you apply a suspension with the API 2, and you are dosifying the API, and the API 2 is separated from the API 1. This is a very, very important application, and it's not complicated. You can do this taking some controls. And the other question is, you have the possibility to do pellet coating. About this, I will present a short case study at the last of the presentation. Well, now a very important aspect is possible to scaling or replicate the coating of equal mass of tablet between a conventional pan and a totally perforated pan, because in pharmaceutical industry, a conventional pan are being replaced by the side-bended ones. So it's very important to be in mind that scaling difficulties in this process from conventional to totally perforated. Let's look at this. This is the typical conventional pen, and this is a typical totally perforated pen. The question is possible to scale, to transfer the process? Well, the answer is this: it's not possible. It's very difficult. It's very difficult. Why? Why not? Because, first of all, the lack of geometry and functional similarity that prevents the scaling or transfer between both equipment. The different geometry of the pans makes it very different. Why? Because the movement of the tablet bed is different. The residence time of the tablet under the spray cone is different. and the air circulation is different. This impact functionally in inadequate balance between the entry and exit of the air in the conventional pan, drying in the superficial in the conventional pan, and cross the bed in the side-vented pan. This will give efficiency in the case of totally perforated pan. It's a very important question. And of course, the application, the uniformity of application is not good in the conventional pan and requires more time to obtain the saturated color. These are this is the difficulties that you have to scale this type of process. Now, scaling up of a field coating process can only be achieved with success if equipment of both scale have not only geometric but two functionalist similarities. This is very important question too. You have here the scalability from development, pilot, and production scale. Here is Revesta development. This is a pilot with the interchangeable drums, and this is the production. So a coating process here is very simple to scale to pilot and the pilot to a production using some characteristic factor of scaling, the index. Okay. Now I want to show you the field coatings. The field coatings are critical factors. It's a triangle, the critical factor, because has three sides. One side is tablet characteristics. The other one, of course, the tablet characteristics means the hardness of the tablet. You need a tablet with a good hardness, a good tensile strength in order to support the process. The friability must be low. The surface of the tablet must not too much rugosity, and the hydrophobicity of the surface must be low, because you need to adhere to fix a polymeric film. So you need a good tablet. This is the first question. Good tablet. This is because we put some attention in the process of granulation, the compression. It's very important to have good tablets. The other question is the coating formulation. Of course, the raw materials, the quality of raw materials, of course, the percentage of solid in the suspension or the solid solution, the viscosity of the suspension or solution, and the surface tension. These are characteristics of the coating formulation. And the equipment and process variable is the other side of the triangle. So it's important to take a look about the equipment and process variables. So we have the setup and field coating variables. As you see, we have 4 blocks: the pan, the air, the liquid, and the guns. And each of one have a characteristic. For example, pan, it's important to the pan rotation speed, the RPM, the drum into the machine is rotating. It's very important variable. The shape, the size, and the number of baffles. Baffles is a structure inside the drum that move and deviate the direction of tablet in the bed of tablet. During the rotation, the baffles increase the mixing of a tablet and enhance the possibility, the tablet uniformity. This is a very, very important aspect. A drum without a pan without baffles is not good, because the bed could move in a very uniform way. You need that the tablets mixing all the time. So you obtain this movement with high RPM of the rotation speed of the drum, and with appropriate shape, size, and number of baffles into the drum. These are two variables, and you can fix this variable as you want. The air is the vehicle that give us the calories to evaporate the water we put with the polymeric suspension or solution. So we need an inlet air temperature, we need an inlet air flow in cubic meters and per hour, and we need an outlet air flow in cubic meter per hour. Here I have to say that the inlet air flow is lower than the outlet air flow. So, in the balance, create a vacuum inside this machine, the closed machine. Remember, the side bender are closed machine. Inside of them, you obtain vacuum because the inlet airflow is lower than the outlet airflow, and the vacuum, more or less 0.1 to 1.0 inch of water, is important because enhance the process of fixing the very small drop of spraying into the surface of the tablet. So it's critical to define this level of vacuum. The other aspect is liquid. Liquid means the suspension or a solution that contains the polymer that will form the film, and the other excipients of the formulation. Let's say titanium dioxide, let's say antiadherents, plastificant, and so on, colorant, of course, if you use. This liquid is is incorporated with the guns that have two lines. One line is suspension or solution lines, comes from the peristaltic pump, and the other line is air with pressure. So the conjunction of both of these fluids into the gun will produce the aspersion, the atomization, the spraying, producing a very tiny drop. This very tiny drop will impact on the surface of tablet and will begin to form the film of the polymeric film. So you have to adjust the injection flow rate of suspension and solution, and you adjust the pressure of air in order to obtain appropriate size drop size. And of course, the flow rate is compassing with the calories you enter in the inlet air flow and temperature. Inlet air temperature and inlet air flow define the calories that you need to evaporate the water you introduce with the suspension. Well, and the other question are the guns. What is the number and the type of injection guns? This is, you have 1, 2, or 3, or more, perhaps 4. It depends on the diameter of the drum. The other question is the geometric configuration of the injection guns. You have the boom. The boom is the axis where you put the guns. So you need to define the distance between guns, the point, the direction of the guns, and of course the atomizing pressure and the pattern, the air pattern of the guns. Well, as you know, as you see, you have many variables, but it's very important to be in mind, because define the quality of the process. Well, here I want to stop and read some questions we received from the audience. Let me see. Well, we have a question from the audience here. Well, excuse me, is it okay, everything?
Yes, Arturo.
Okay. Well, the first question I received is, how long does the coating process take? Well, as I say, in the competitive pharma industry, we need to reduce the time of the processes, and of course, the process of coating in a side banded with all atomization is good. The time is short, but in order to show an example, let's suppose you have to introduce 50 kilograms of coating suspension, yes, into the batch of let's say 200,000 tablets, and well, the process time, the coating time will depend on the spraying flow rate, of course. If you use, for example, only two guns, and the whole flow rate of injection is 0.5 kilograms per minute, well, you will have 100 minutes to finish the process. So less than 2 hours and a half to coating 200,000 tablets in only 1.5 hours. Of course, you can introduce a third gun and increase the flow rate. In this case, of course, you will need to increase the air, the inlet air flow, in order to increase the calories you need to evaporate the increasing in the water incorporated into the bed. But well, I think that is the answer for this question. Okay. Another question is, say, in order to dosify an API using vented tablet coating pan, what are the critical process variables? Okay. Well, this is the case of application I told before. Coating as a process to apply quantitative API. You use the machine to dosify an API. Well, in this case, the main variables in order to success with the dosifying API in the core, in the tablet, is the pan speed. You need that the pan speed will be high, the RPM high. Why? Because you need that the tablet path many times under the cones of the spraying. So you need a very high RPM. This is the first question. The other critical variable is that you need to incorporate the solution of API with polymeric excipient in a medium or low flow rate. So this conjunction, these two variables, high in speed and low in injection, will produce the best content uniformity of APA in the tablets. This is the critical question. In a second category of critical variables, you can use, in this case specifically, when you dosify an API with a coating machine, use the baffles, the hollow baffles, 2 or 4 baffles, because these baffles will introduce a good mixing of the tablet into the drum, and this will enhance the uniformity of application. Well, these are the two questions. Well, now I continue with the Mauro, some question? Hola.
Sorry?
¿Escuchan?
Can I ask something about the API? If it's good for coaching or not? Can we look for that before starting our process in coaching?
Okay. When you have the tablet storage, is common to the hardness reduce. Okay. Okay. It's a good question, but for me, it's very difficult to give a solution or an explanation. What we know is that when we finish the tableting, the tablet have a hardness and have a thickness. Then the tablet goes to the storage, and during this time could modify the thickness, for example. This means the post compression expansion, because the tablet have a elastic component. This expansion different in the time could affect the hardness, could affect the hardness. This is very known. But in the case how we can track this process, you need to measure at different times the evolution of the hardness. I believe, of course. And have you ever met the cases when the hardness of tablet doesn't change during storage, but release of API decrease? Yes. When during the storage, the tablet gain moisture, for example, gain moisture, could not affect the hardness, but it's possible that the dissolution profile or the time to dissolution X% change. This is common. Decrease the dissolution. Yes, the mechanism of this process is variable. I think it's depending of the type of excipients, the fillers, the binders, of course, the API, etc. And another question is, what coating is good for dosifying API? Remember this: when you want to dosify an API, you have to solve you need to solution of the API. It's not possible dosifying suspension of API. You need a solution of API. So normally we use a polymer, HPMC 9%, without titanium dioxide, but with a plastificant, of course, it's very necessary, and with anti-adherent. So the polymer is HPMC, not use of titanium dioxide, use an anti-adherent, and use an plastificant. You need use water if the API is soluble in water, or water and alcohol, or alcohol, ethanolic alcohol, if the API is soluble in this. This solution is called clear solution. Contain the API, and you spraying over the tablet, and the API is fixed in the surface. After this, you need to cover with a coating with color and with all the components. We continue with the webinar. Now I wanted to show you problems or difficulties in the quality of the tablet, because as I told when I start, when you are coating tablet, you have the problem that you put solvent in the tablet, and the tablet could wet, could friabilize, could over dry, and a lot of problem appears during the process if you not control the coating process. So I want to show you this aspect. The problem is very, very extensive, and we don't want to overwhelm you with information, but just some of the typical problem. No, of course, the typical are, for example, picking and sticking tablet. You have at the right a typical picture. These are picking. The orange peel or roughness, the surface are like an orange peel. The lack of uniformity in the color of a tablet with a more blue, little blue, this is not good. And the tablet edge erosion are another problems. Again, exist and other problems, but these are very common. So picking, the cause is overwetting due to an imbalance between the suspension injection that exceed the drying capacity. We said this before. So what is the solution? Reduce the suspension rate or increase the temperature and or the drying air flow rate. So you compense. Orange peel means excessive dry due imbalance between suspension flow and the high temperature or drying air flow. So what you need, increase the suspension flow and reduce the temperature. Another possibility is high automation air pressure. So if the air pressure is very high, the drop is very teeny, and the very teeny drop dry before reach the surface of tablet and impact in a dry state and impact and fixing the surface and produce this roughness. So only you have to do is adjust the pressure. Coating suspension with high viscosity, so you have difficulty to atomization, produce orange peel, well, dilute the coating suspension. The lack of uniformity, well, poor cascading of the tablet bed, increase the rotational speed. It is a very simple way. Irregular suspension of flow rate. Remember, the suspension, the polymeric suspension with water is by a peristaltic pump. The peristaltic pump use a hose or tubes, silicone tubes. The distensibility of the tubes fall in with the use. So if the distensibility fall, the flow rate reduce. So in these cases, you have irregular suspension, and part of the tablet will receive more and the other parts receive less. So the uniformity is not good. The other question is when the guns are overlapped, so you need to separate the guns into the boom, pointing to the bed. So it's a problem of adjustment of the position. And variation in drop size is the other question. Is what you need is atomizing pressure adjustment. And tablet erosion, well, this wear is caused by excessive loading of tablet in the drum, the depth of the bed. So perhaps if you only reduce the batch size, perhaps you have a solution. Another possibility is that this this erosion is because the high speed of rotation of the drum, so reduce the velocity. And well, of course, if you have tablets with little or small hardness or high fiability, of course, what you have to do is enhance the tablet quality. Now I want to show you the pharmaceutical area and the technical area of a coating process. The black line separate both. As you can see, pharmaceutical area below, and in the upper part, you have the air treatment line, because the external air have normally high levels of relative humidity and absolute humidity, of course, particles, microbials, etc. So you need treat this air in this air treatment line. So the air pass through a cooling coil for eliminate the absolute humidity reduction. Then the air pass through the coil that heating and reduce the relative humidity. Here you have the air injection turbine. This is the motor that inject the air. Of course, you have here an HEPA filter because you need air with a pharma quality. This is very, very important. And well, the air into the ductus going to the drum. And this is very important because this drum, as you can see, is perforated, totally perforated. It's not blind as a conventional pan. So the air pass through the bed, and the efficiency of drying is very, very high. So here we have the air. Let me show you that here in red is hot air. The hot air pass through the tablet, remove the water, reduce his temperature, increase his absolute humidity and his relative humidity, and so is here is with low temperature, high humidity, absolute, and high relative humidity. This is and so the air treatment. Well, but how the operation of the totally perforated pan, the side vented? Well, we have the scheme. These are the perforated drum. Here we have the baffles, the hollow baffles. The hollow baffles are very, very good, these baffles, in order to good mixing of the bed of tablet. Here we have the bed of tablet with inclination because this drum is moving. And here we have the boom with the guns. And here we have another element very important, that is a sensor, a temperature sensor. Temperature sensor controls the temperature of the tablet. So let me show you. Inlet air here, inlet air. The inlet air has a high temperature because this means calories, has low relative humidity because we remove in the treatment of air, and have inlet airflow X meter cubic per hour. Well, this entered and the drum begins to move at RPM. This is drum speed. Start the suspension injection at the spring rate defined. This means it continues, and the air exhaust with low temperature, high humidity, and with the inlet airflow rate Y. Y is bigger than X. So inside the drum, you have vacuum. Vacuum in the order of 0.1 to 1 inch of column of water. Well, but the very important question here is that the sensor, this temperature sensor, controls the process, because we need that the temperature measured by this device kept constant. If this temperature is kept constant, that means we have a thermic equilibrium, and means that the tablet are not wetted and are not dryness, not overwetting and not over dry. So this is the key of the process to reach equilibrium, a thermic equilibrium. So the Revesta machine of coating have many sensors and the possibility to not only monitoring the process, but the modulation of the coating process. So look at this. You have here temperature versus time. The temperature of the drying air, the hot air with flow rate and low relative humidity. And as you can see, here is the temperature of tablet air exhaust, which is measured by the PAN sensor. The PAN sensor permanently are measuring the temperature of the tablet. At the beginning, the temperature is low, but the pre-warming, because the temperature is in the order of 70 degrees, the temperature increase, and now is here with a high level, let's say 45 degrees, and this is the RAM heating and modulation. Okay. Now, if we on the suspension injection, the polymeric suspension, here we will note a depression, a minimal depression of the temperature of the tablet, because the sensor detects a reducing temperature. So, but increase and return to the temperature of, for example, 45. And during this time, this constancy, this constant temperature means that the process is in a thermical equilibrium, and no problem about the quality and the structure of the tablet is affected. It's very good condition. So we need to reach a thermical equilibrium, and the sensor of the temperature of the tablet, or it could be to the sensor here, because you have this sensor, but you have here another sensor that measure the air pass through the bed, but both measure more or less the same temperature. So it's very, very critical, this sensor that is connected with the PLC in order to modulate the process. Okay. Let's suppose here we are with a process, a stable process, no problem, equilibrium, and well, finish the process at the 80 minutes, for example. Cooling, we turn off the vapor or turn off the resistance of heating, and temperature fall, and the process is finished. Here, well, is another explanation about monitoring and modulation. Here we have this question. The process is here, is in a thermic equilibrium here, but in a moment, the flow rate from the peristaltic, the flow rate fall. If the flow rate fall, occur a disbalance between the solvent and the calories to evaporate it. In this case, we have an excess of calories. So the temperature increase, as you know, increase. So the steam valve control or the resistance deactivation in order to reduce the temperature, and the temperature reduce, and you obtain again the equilibrium. But then you, let's suppose, remove the tubes of silicone in order to enhance the flow rate. So here, increase the flow rate. The water going to the tablet increase. So a little depression in temperature occur, but this is detected by the PLC and respond increasing here, increasing the activation of valve of the resistance. So the thermical equilibrium is reached again. So Revesta film coating machine have not only a configuration of a structure configuration and variable configuration, and a system with monitoring and modulation of the process in order to avoid any problem derived for problems of flow rate or could be to excessive temperature. These are very controlled process. Well, finally, I want to show you a case study, because pellets are pellets. I mean pellets. The pellets obtained by extrusion spherization process are very common in these days. And as you know, the pellet with a cellulose based could be coating with a Guster bottom spray, but it's very difficult because you have to control many variables. The problem of sticking, well, it's not easy, and a limitation of capacity. But the pellet, the cellulose pellet with API could be coating using a totally perforated pan. But the normal pan have holes in the drum. The drum have holes of 2 millimeters, and the pellets are only 1 millimeter of diameter, are spheric of 1 millimeter of diameter. So it's not possible to use a typical machine with this type of hole. Here we will show this type of drum, perforated drum. Look at this. This is this. Here we have this structure. The drum, the perforated drum, are not cycles of 2 millimeters of diameter, but are long apertures with 500 microns. 500 microns retains the pellets, the ferric pellet. These are the pellets of cellulose with active. So the pellet distribution, the typical pellet distribution is this. So you have here 500 microns here. So the big or the great majority of the pellet is possible to coat in here into this machine. And you don't need to adjust, to set up the complicated bottle spray process, and you increase a lot the capacity of the process. So Revesta have a innovation about the perforated drum, because this type of windows, long and narrow, let the air pass through, but the pellet are not loose. Okay, here we have a typical process in the machine. Well, this is the last slide. You remember before that we put emphasis in the quality of the product, and the process efficiency depends on the technology. We have, and I think we all we think about the technology is the most important, but it's not sufficient. It's not enough. Beyond the technology, they also depends, the efficiency and the quality depends on a particular solutions. And we have the idea that the quality and efficiency depends of the raw materials and formula and the manufacturing process. This trilogy is very important. You can have the high technology, but if you have bad raw materials or formula or bad manufacturing process, the quality and efficiency will not good. You need to equilibrium between these three parts. So the solution, of course, the selection of raw materials, the purchase specification, very sharp, quality and quantitative composition. To know formulation tips is very important, and to have expertise. In the order of manufacturing process, you have another aspect, because let's suppose you have the very good technology, the very good raw materials, and very good formula, but the manufacturing process is not conducted in a good form. Well, you will have a problem. So configuration of production lines, the setting of the process, the scaling up if it's needed, the specification application, and the methodological tips and the expertise are very important. So these are questions that from PATGROUP we have give you solution in order to give quality and efficiency process. Well, thank you for your attention, and well, questions.
Thank you, Arturo. for this second part of the exposition. It was really interesting. And we have some questions before we go with it. Please remember that we have activated the survey on the screen, so we appreciate if you can answer it. Yes. Now, regarding questions, we have a comment from Peter, I understand. It's how to apply a coating without TiO2 so that the color is full. Is there any solution? Thank you. So the question is how to apply a coating without TiO2. I don't know if you understand what is TiO2. TiO2.
Yes. Titanium oxide. Titanium oxide is a very important excipient in, I say, in every suspension of a coating suspension. If you, because the titanium dioxide is the support, is the base in which the colorant will be fixed, will be bind. If you put the coating without titanium dioxide, the problem will be that the color will not good. You need the opacifier. The opacifier is this, is the titanium dioxide. I really don't know if it's possible to replace titanium dioxide with other excipient, but you need to bind the color to a structure. This structure is the opacifier. The typical opacifier is titanium dioxide. When I was in development area, we tried to eliminate titanium dioxide or reduce titanium dioxide of our formula, because titanium dioxide could affect the life of the gun. So what we know was that the color is not good. The color is not good. You need to put titanium dioxide as opacifier in order to obtain a good color. Is good? Is correct?
I understand it clearly. I hope it too. Then we have one more question. It says, what scaling factors are used in fully perforated pans?
Okay, yes. As I told before, remember, you need equipment in the development area and the pilot production area that meet the same geometry. It's not the same, the conventional pan to a perforated pan. These have not geometrical similarities. You need, so geometrical similarity is very important. It's very important. The other similarity you need is the dynamic similarity. What that means, dynamic similarity? Dynamic similarity means that the movement, the acceleration of the tablet inside the drums will have the same in short scale and big scale. And this, you can obtain this dynamic similarity using a Froude number. Froude number is a number that you have an equation, is diameter of the drum times RPM, the revolution, times RPM divided gravity. So let's suppose you use a very small pan in the develop process. You use a very high RPM. Well, but you have a small diameter, high RPM. But then you go to production. In production, you have a very big diameter. So you need to reduce RPM in order that the product of diameter times RPM at the second potence will be constant. If you reach this flow number constant in both scales, you will obtain the dynamic similarities. So you have the geometric similarity and you have the dynamic similarities. This is the principal, the main questions. Of course, then you have to scaling, for example, the spread rate. The spread rate, let's say, grains per minute of the suspension. But this could be scaling, for example, keeping constant the number of tablet inside the spraying cone, respect the total number of tablets. Let's say, imagine you have a very small side bended in development. You point the gun against the bed of tablets, and the cone is a circular cone, and in the circular cone you have n tablets, a number of tablets. You have to count this 1, 2, 3, 4, 60 tablets in this cone. So take it this number divided the total number of tablets inside the drum will be keep constant when you pass to the pilot or the production. You go to the production, and now the cone is very big, but the size of the batch is very big too. If you maintain the number of the tablet into the cone or under the cone, divided the number of total tablet, well, this could be a good parameter to adjust the flow rate of a brain. Yes, but you could try, experiment, adjust, but the most important is geometric similarity and dynamic similarity. If you have these two principal factors, the rest is not important. You will reach the solution for the flow rate and the flow of the air you need to reproduce in pilot or production process the develop you make in the small scale.
Thank you. Thank you very much, Arturo, for the explanation. It has been really interesting. Not only this question, if not all the 6 webinar edition. And well, it's already time to finish. All the pending questions will be answered by email. And really, it has been a pleasure to have all of you participating in all these webinars. Yes. So once again, thank you very much, Arturo. Thank you very much, all the attendees from countries all over the world. And let's keep in contact whatever you need. Yes, we're here to support.
Okay, thank you.
Thank you, Natalia.